Hey guys, what's going on? Mr. D here with the new section on Chapter 6, which is 6.2. So today we're going to be taking a look at multiplying and dividing exponential expressions. So what we're going to do is go ahead and recall a little bit of our properties of exponents, and then we're going to actually go ahead and apply those to a few multiplication and division problems. So why don't we go ahead and get started right away with our first problem here. So remember guys, the product rule, okay, so this is the product rule, all right, and on our product rule is basically when we have things with the same base and we can just go ahead and add their exponents, just like we have here. We can add the exponents on the product rule. So let's go ahead and find things that have the same base. So here I notice that I have two x's and I also have two b's. So what I can do with my numbers here, however, I have a 3 and an 8, so I can multiply this, because remember, this whole expression is just multiplication. So what do we get? We get 3 times 8, that is a 24. And yet again, remember, here in red, I have my x's. So I'm going to write an x. And like we said earlier, the product rule says that we can add the exponent, so this is x to the 7th. And then finally, with my v's, we have 3 plus 4 and also v to the 7th. So that's just a quick recap of what the product rule is. Now let's go on to the division rule, which is almost like the exact opposite of the product rule. So our division rule says that we can subtract the exponents. So let's go ahead and try to reduce this fraction here. So first off, let's go ahead and reduce these numbers that are in front of here. So what do 3 and 27 have in common? That they're both divisible by? Hopefully you are identifying that they have a 3 in common. So 3 divided by 3 should be a 1. 27 divided by 3 should be a 9. Okay, now we're going to go ahead and take a look at the bases of x. So we have x to the 7th and x to the 12th in the bottom. So let's go ahead and start writing my answer here. So I definitely have a 1 on the top and a 9 on the bottom. Now my x's, this is where we ask ourselves who wins. So again, who wins? Okay, so we have x to the 7, x to the 12. Which one has more? The bottom one has more. So the bottom wins. So I'm going to go ahead and write my x in the bottom. And then you ask yourself, how many more did the bottom have than the top? Well, it had 5 more. And again, how did I figure that out? Well, all I did was do 12 minus 7 to get 5. So that's all I did there. So let's go ahead and continue. All right, so that was my x's. So now I can go ahead and erase this. Now I have to look at my y's. So go ahead and I'm going to go ahead and highlight my y's here. So that's y to the 7th and y to the 2nd. Which one has more? Well, hopefully you guys can identify that the top has more. So I'm going to go ahead and write my y up there. And how many more did the top have than the bottom? Well, that would actually be 5. So my final answer is this right here. And if you wrote it without the 1 up there, guys, that's totally fine as well. So if you just wrote it like this, excuse me, then that is also a correct answer. All right, so that was our division rule. Now let's look at our power of a power rule. That's when we multiply the exponents. So, excuse me, sorry about that, guys. So this is when we already have a base, in this case z, and it's raised to the 8th power, but then it's raised again to another power. That's when we basically distribute this power, meaning we have to multiply those two numbers. So my base stays the same, still a z. However, now we get a 32 because 8 times 32, I'm sorry, 8 times 4 is 32. So that is my power of a power rule. So that's when we multiply the exponents. All right, let's move on to number 4. This one here is the power of a product rule, which is again basically when you have to distribute the exponents. So let's take a quick look at this. So on this first one here, remember this is 5 to the 1, and this is y to the 1 as well. But I have all those bases. I have a 5, an x, and a y, and they each have their exponent. But then I'm raising it to another power, so I have to distribute, or in other words, I have to multiply each of those exponents. So this is going to be 5 to the second, x to the 12th, and y to the second. But I can actually figure out what 5 to the second is. That's actually a 25. So this is my final answer. And if we have a quotient here or a fraction, we do the same thing. Just distribute it to both of those. So again, I have a base here of x and y. So I'm going to go ahead and write my x, my y. So 7 times 4, that is a 28. And then 3 times 4 is a 12. I can't reduce that at all because those are different bases. So that is what you would get for this problem. Okay, so basically just distributing out that exponent. Now, we also talked about in the last lesson about negative exponents. For negative exponents, we just have to remember, if they're negative in the numerator, we have to drop them down. If they're negative in the denominator, we have to bring them up. And every time you do each one of those movements, we just have to turn the exponent now into a positive. That's all a negative does. It makes us move it either to the bottom or to the top, and then we have all positive exponents. Let's take a quick look at this. Let's make sure we don't confuse exponents with numbers. This here is a number. Okay, it's okay if it's negative. We're only talking about rules of exponents, so you only have to pay attention to the negative exponents, and the only negative exponents I see here are but y to the negative third and w to the negative fifth, meaning that we don't have to move these guys right here. There's no need to move these guys. Keep them where they're at. So why don't we go ahead and do that? So this is going to be a negative 2x to the sixth. However, this y to the negative third, I'm going to move it down. And now it becomes a positive 3. And this w to the negative fifth has to come up. So this is going to be w to the fifth. And I cannot reduce that at all because those are all different bases. So this is my final answer. All right, last one. We talked about exponents of 0. Okay, so let's go ahead and highlight this real quick. So whenever we have an exponent of 0, so if we raise anything to the 0 power, we will always get a 1. So let's recall what that means. That means all of this in here, so let me highlight it. It doesn't matter what you have in here at all. It could be negative 8 million, a to the 50th, and b to the 20th, because if it's raised at the very end by these parentheses here, okay, these parentheses trap it all, and then it's raised to the 0 power, well, anything to the 0 power will just be a 1. All right, so let's go ahead and take a look at a few practice problems. We're going to actually start off a little bit easy here. We're going to go ahead and multiply regular fractions, and then we're going to see how that transfers over to multiplying exponents. Okay, so let's go ahead and talk about this first one. Well, let's see. We have 2 divided by 3 times 21 divided by 6. Or another way to say it is 2/3 times 21/6. Okay? Now, be careful here. I know a lot of people are going to try to do this. They're going to try to say, oh, well, what we have to do here is cross multiply that and then cross multiply this. No, that is not what we have to do here, guys. We would only do that if this was something like this. If it was 2/3 equals 2/6, then we cross multiply, but we are not setting up a proportion here. We have a multiplication. So what we have to do here is we do have to look across at these numbers, this 2 and this 6, and we have to try to reduce them. Okay, so this is what we're going to do. What do 2 and 6 have in common? Okay, meaning, what can I divide both of them by to get a whole number? Well, if you guys notice, those are both even, so I can definitely divide them by 2. So 2 divided by 2 is a 1. 6 divided by 2 is a 3. All right, so I reduced those. That's going to help me out later. So why don't we go ahead and do the same thing with the 21 and the 3. What do those two things have in common? Let's check it out. Well, 21 and 3, the only thing I can think of is a 3, okay? Because 3 divided by 3 is 1. 21 divided by 3 is a 7, okay? So what do we do now? Well, all we have to do now is actually take the two numerators, so 1 and 7, multiply them to get a 7. Take my two denominators and multiply those. We get a 3. All right, so our answer here is a 7 divided by 3. Now, you might ask yourself, or you might say, well, Mr. Dorado, couldn't I have just multiplied the tops and then multiplied the bottoms and then gotten the same answer? And I would say, yes, you can. The only difference is that you're going to end up with pretty big numbers here. So if you took your original, so go ahead and have all this copied down because I'm going to erase some of this. Okay. So if you had your original 2 times 21, that would have been a 42. If you did 3 times 6, that would have been 18. You can actually reduce that, guys. And what these two numbers have in common, again, is actually a 6. And notice what we're going to get for our answer. 42 divided by 6 is actually a 7. 18 divided by 6 is a 3. Look at that. It's the exact same answer. But what you want to do here is the method that we did first, okay? The reason why you want to do that is because it's going to help you out in the long run, okay? It's better to work with small numbers than with larger numbers like the 42 and the 18, okay? So why don't you go ahead and take a look at, well, actually, let's do it together. Let's go ahead and take a quick look at number, or this other one over here on the right, so we can go ahead and solve it. So same thing. Remember, you're not cross multiplying, you're just looking at the numbers across from each other to see if they can be reduced. So I ask you now, what does 9 and 81 have in common? Well, they're both divisible by 9. So 9 divided by 9 is 1. 81 divided by 9 is actually 9. Same thing over here. What do 5 and 30 have in common? Well, they have a 5 in common. So you have to be careful here, though, because negative 5 divided by 5 is a negative 1. 30 divided by 5 is a 6. So once again, what you have to do here is take your two numerators, which is negative 1 and 9, and multiply them. And then take your two denominators, 1 and 6, and multiply those. And actually, you'll start to notice something here. Okay, you can reduce that even further. What do 9 and 6 have in common? They have a 3 in common. So if I divide both bottom and top by 3, I get a negative 3 on the top and a positive 2 in the bottom. Okay, so that's negative 3 halves is your answer. Again, if you would have just multiplied the tops and multiplied the bottoms, you guys would have ended up with some huge numbers. So try to avoid that, guys. Okay, all right, so let's go ahead and see if we can solve the following problems. So let's go ahead and take a look at number 1 and see what we get. It says, simplify the following expressions. All exponents should be positive. All right, so let's check this out. Well, at the top, again, I'm going to try to reduce here at all, if I can at all. Well, what number is in front of here? That's a 1, and in front of here would be a 1. So if I look at my two big numbers here, so the 3 and the 1, can't really reduce. And the 1 and the 2, I can't really reduce because I already have 1s here. So what I'm going to do is go straight to my second step, which is to multiply across. So what do I get? If I multiply the tops, I get 3 times 2, that's a 6. And then I have an x to the 5th and y to the 2nd. Okay. Now let's look at the bottoms. What do I have? I have a x to the 8th and y to the 2nd. And yeah, I did flip those two, but I'll show you exactly why I did that. I did that because now I can actually apply my division rule, meaning I can check which one wins there, and I can check which one wins there. So let's go ahead and solve that. So what do we get? Well, the 6 stays just as it is. Let's figure out the rest of it. So in my x's, which one has more? Which one wins? The bottom one wins. It has more. So I'm going to place my x right down there. So now I ask, how many more does the bottom have than the top? Well, it has 3 more. All right. Now my y's, which one wins? Well, actually notice that they're both the exact same number, so none of them win. I can cross them out. So my final answer here is actually just 6 divided by x to the 3rd, and that is my final answer. Okay, let's move on to number 3. Again, let's go ahead and see if we can figure this out. All right, let's take a look at our numbers. Again, I like to look at the numbers first because I can try to reduce those if ever possible. All right, so let's take a quick look at those. So once again, we have 4 and 16. Well, what do they have in common? Well, they have a 4 in common. 4 divided by 4 is 1. 16 divided by 4 is 4. Let's look at my 10 and 5. What do 5 and 10 have in common? Well, they can both be divided by 5. So 10 divided by 5 is 2. 5 divided by 5 is 1. All right, so now I'm going to go ahead and multiply across the top. 1 times 1 is just 1. And then I still have my x to the 6th and y to the 9th. All right, and at the bottom, what do I have? 2 times 4, that is an 8. And then again, I have a y to the 5th and an x to the 3rd, but I'm going to actually place my x to the 3rd here and my y to the 5th here. So I can now apply my division rule so I can check which one wins on my x's and which one wins on my y's. So let's finish this problem up. So again, I don't have to play the who wins game with the 1 and the 8, so I'm going to go ahead and rewrite them. Now let's ask ourselves who wins on the x's. Hopefully you are saying that the top wins. So as soon as you say the top, go ahead and write the x there. How many more did the top have than the bottom? Well, it has, whoops, sorry about that. It has 3 more. Again, how did I get that? I just took the higher exponent minus the smaller exponent, and I got my answer. So now we have to go ahead and check the y. So let's see what we get there. So y to the 9th and y to the 5th, which one wins? Actually, the top wins again. How many more did the top have than the bottom? It had exactly 4 more. So this here is my final simplified and reduced answer. Alright guys, why don't you go ahead and try numbers 2 and 4 for me, and then we'll come back to verify that you have those correct. Alright guys, why don't we go ahead and take a look at number 2 here. So, again, we want to double check if we can reduce anything. Remember, this here is a 1. This here is a 1. So if I look at these two, I can't really reduce because I already have a 1 there. And this 14 and this 1, I can't really reduce there because I also have a 1. Okay? The only thing divisible by 1 is 1. So, or I should say the only thing that divides 1 is 1. So, let's go ahead and Actually, hopefully you noticed this. Notice that the 14 here and the 7, they have a 7 in common. So you can actually go ahead and go straight to that. 14 divided by 7 is 2. 7 divided by 7 is 1. So you can actually reduce like that as well, guys. Remember, you can cross-reduce or you can reduce the fraction itself. Okay? Any fraction can be reduced right from the get-go. But let's go ahead and continue. So here, what do we get? On the top, I get 2 times 1, that is a 2. And then I also have an x and a y to the third. I like to write the exponent on the x just to make sure I have the right amount. And then in the bottom, I have 1 times 1, that is a 1. And then I have 1x and 1y. Okay, let's keep going. I can now play my who wins game here by looking at my x's. And I'm also going to look at my y's. So let's see what we get. All right, well, we don't have to play the who wins game with my 2 and my 1. So now with the x's, x to the 1 and x to the 1, they're the exact same. So I can cross them out. There's no need to even put them down anymore. Now let's look at our y's. Y to the third over y to the 1. The top definitely wins. And it has exactly 2 more than the bottom. And now if you did want to write it a little more simple, you could just write it as 2y to the second. Anything over 1 is just that same expression. You don't have to go ahead and leave it as a fraction. All right. I think, let's see. Actually, let's do this one. Yeah. Again, guys, if you can reduce these numbers first, remember, these are just numbers, not exponents. So I like to reduce these numbers first. If you don't want to do that till later, that's fine. But trust me, it's much easier if you just reduce them now. So let's figure this out. What do the 6 and the 2 have in common? They're both divisible by 2. So this 6 divided by 2 is 3. 2 divided by 2 is 1. What about 12 and the 9? What do they have in common? What can they be divided by? Hopefully you are saying 3. So 9 divided by 3, I'm sorry, yes, 9 divided by 3 is 3, and 12 divided by 3 is 4. Okay, let's keep going. So what do we get at the top? 4 times 1 is 4. And then I also had an x to the 12th on the top, and a y to the 9th on the top. Okay. Now I have a 3 times 3, that's a 9. And then notice again, I have a y to the 9th and an x to the 7th. But I'm going to actually put my x to the 7th there and my y to the 9th after that. Because now, again, I like to just show with my highlighter here that I'm going to have to play my who wins game, basically my division rule, with these exponents and these exponents. Okay, so let's see what we get. This is 4 over 9. Again, that doesn't change because those are not, those don't have any exponents there, so I just leave them as 4 over 9. And then my x is x to the 12th over x to the 7th. Which one has more? The top has more. How many more did it have? It had exactly 5 more. And then with my y's, notice they're the exact same exponent, so they actually cross out. And my final answer here would just be 4x to the 5th over 9. All right. Now, guys, if you feel comfortable with that method that I've just been using, continue to use it. I really do like this method because I can see and compare my x's and my y's so I can see who wins, and there's not so many things that are being crossed out. However, if you feel confident and you feel good about these types of problems, you can do a lot of this stuff right from the get-go. Okay, and I'm going to show you exactly how to do that right now. Okay, so once again, let's go ahead and I'm actually going to go ahead and start by putting my brand new fraction symbol right there. Okay, and just like before, let's keep going. The negative 12 and the 6 I can reduce, and then the 7 and the 28. Okay, so let's see what I can reduce these to. So what do negative 12 and 6 have in common? Well, they can both be divided by 6. So negative 12 divided by 6 is a negative 2. 6 divided by 6 is a 1. Now on my yellow numbers, 7 and 28, they have a 7 in common. So 7 divided by 7 is 1. 28 divided by 7 is 4. Okay, so I'm not even going to do anything with the m's and the n's just yet. What I want to do is just go ahead and transfer what I have now with my numbers over to my new fraction bar. Okay, so negative 2 times 4 is a negative 8. 1 times 1 is a 1. Okay, make sure you have that written down, guys, because again, I'm going to be doing a little bit of erasing here. All right? So, what you can do as well, this doesn't only work for numbers, guys. This also works out for the different bases that we have here. Notice here on the left, so again, let me erase this real quick. I can do the same thing with the similar bases. So here I have an n to the 4th, and here I have an n to the 3rd. Okay? I can already start to play my who wins game. Okay? But actually, you know what? Nah, I don't think I'm going to go this route, guys. I don't think I'm going to show you that method just yet. I think you should continue with the way we were going up until now. I think this is a little bit more advanced, and I'm afraid you guys might not quite understand it just yet. But I will actually try to make a new video to see if that helps a few of you guys out. But what I'm going to go ahead and do is just continue solving like we have been. So let's go ahead and see what we have. So what else was in the top in the numerator? That was n to the 4th and m to the 5th. Now, be careful on the bottom. We have an n, an m, and an n to the 3rd. Again, those two have an exponent of 1. So in the bottom, if I'm multiplying n to the 1, let me highlight it here, n to the 1 and n to the 3rd, that's our product rule. We can go ahead and add those exponents. So this is really an n to the 4th and an m to the 1. Okay, and this is the reason why I want to continue showing you the way I have up at the top, because I want to make sure you guys don't get confused and continue doing this in a proper fashion. Because now, again, I can compare my n's and I can compare my m's. All right, so let's see what we get. Again, no reason to change that negative 1 and the negative 8 and the 1. I'm just going to go ahead and rewrite them. Between my n's, I have n to the 4 over n to the 4. Those are the exact same, so my division rule tells us that I subtract 4 minus 4, which is 0, and anything to the 0 just reduces to 1. So no need to write it here. M to the 5th and m to the 1, which one wins? Well, the top wins. How many more did the top have than the bottom? It had 4 more. So my final answer here, I can actually write it as negative 8 m to the 4th. Okay, so I do apologize for that problem, guys, on number 5. I was going to show you a different method, but honestly, let's go ahead and keep it simple for now and make sure we understand it. Okay? All right. This is what we're going to do for number 7. Okay, before I even do anything with this multiplication here, I'm going to go ahead and change something. Notice right off the bat here that I have a negative exponent there, and I have a negative exponent there. We don't like those negative exponents, okay? We want to make sure we get rid of those ASAP, all right? So this is what I'm going to do. I'm going to concentrate on this left side. Concentrate on this, guys, okay? Don't even worry about this other side. If you want, go ahead and block it for now. Okay, I'm going to go ahead and erase it for now. What I want to do is rewrite this first one. Okay, we'll go ahead and rewrite this fraction so that it doesn't have any negative exponents. So everything stays exactly the same. The only one that I have to move is this x to the third, which is now going to go to the bottom. So this is going to be 12 y to the fourth over 6 y to the fourth and x to the third now. Okay? Notice how everything has a positive exponent now. All right. So after doing that, I can now uncover this side again and try to handle this right side. So I'm going to go ahead and highlight it here. So now I have to take care of this. But again, notice I have that negative exponent, so I have to move it to the bottom. So let's go ahead and do that. So let's see what we get. So I'm going to go ahead and move this to the bottom so I can rewrite everything except for that y. So it's going to be 2x to the fifth over 18 x to the second, and then I'm going to bring down my y, which is y to the first. All right, so now I can go ahead and solve this just like I solved number 5. So I'm going to go ahead and try to reduce my numbers first. So the 12 and the 18, and also the 6 and the 2. All right, let's figure out what these reduce by. 12 and 18, what do they have in common? They have a 6 in common. So I'm going to go ahead and do 12 divided by 6, which is just 2. 18 divided by 6, which is 3. Now I look at my 2 and 6. 2 and 6 have a 2 in common. 2 divided by 2 is 1. 6 divided by 2 is 3. Okay, so what do I have at the top? So I have 2 times 1 is 2, x to the fifth, and y to the fourth. Again, guys, the only reason why I'm moving those around is because I like to have them in alphabetical order. Okay, so x and then y. All right, now let's look at the bottom. I have a 3 times 3. That is a 9. And now again, I like to have my x's first. So look, x to the third times x to the second. That's my product rule. So I have to add my exponents, which is actually x to the fifth. Same exact thing with my y's. I have a y to the fourth times a y to the 1. So this is y to the fifth. Okay, let's finish this problem off. So I can go ahead and rewrite my 2 and my n because the only thing I have to do now is apply my division rule here. Okay, so basically, who won? All right, so with my x's, notice they're both x to the fifth, so they actually cancel each other out. In my y's, I have a y to the fourth over y to the 5. So basically, the bottom wins, and by how many more? By 1. So my final answer here is just 2 over 9y. Alrighty. So definitely a lot more intense and a lot more work, but at least now we have a little bit of an understanding of how these work. But remember, guys, that should be your goal. Try to get everything with positive exponents and then continue solving just like we have before, or rather continue multiplying just like we did earlier. All right, let's go ahead and handle number 9. Same thing. Notice right away, have a negative exponent here and a negative exponent there. So I have to rewrite this whole problem with positive exponents. So let's go ahead and do that. All right, so what do I get? We have a negative 1 w to the third, x to the fifth. There was no reason to change that at all. Okay, but notice now I have to bring up this y to the fifth. So I'm going to rewrite it, y to the fifth. In the bottom, I have a 5. I'm sorry, not y. I keep saying y. It's w to the fifth. So then this w to the negative fifth was moved up. So the only thing I really have to write now is x to the 12th. Okay. On this other side, what do I have? I have 5 w to the second, x to the third. And again, this negative w to the negative fourth has to go up. So this is w to the fourth. All right, so now I just keep in the bottom a 7x to the fifth. And once again, I have now all positive exponents. I can begin solving my problem. So I'm going to compare those two. I'm going to compare those two and see if those reduce at all, and then we'll multiply across and see what we get. So let's see, the negative 1 and the 7, do they have anything in common? Well, they have a 1, but if I divide by 1, they're going to stay exactly the same. So I can't change those, but what about my 5s? Well, they're both divisible by 5, obviously. So this 5 divided by 5 is 1, 5 divided by 5 is 1. I can now go ahead and write my my multiplication of my numerators and my multiplication of my denominators. So at the top, I get negative 1 times 1. This is a negative 1. Now let's look at the W's. Okay, guys? Let's take a quick look at my W's here. So I have a W to the third, W to the fifth, W to the second, and W to the fourth. Okay, again, every single thing in this numerator is being multiplied. So it's the product rule over and over again. So I can just add all the exponents of my w's to find my answer. So 3 plus 5 plus 2 plus 4 is what? Okay, 3 plus 5 is 8, 8 plus 2 is 10, 10 plus 4 is 14. So we have w to the 14. And then finally, I have my x's here. X to the fifth. Whoops, let me get a highlighter here. X to the fifth and x to the third. Again, product rule, so I add my exponents to get a x to the eighth. Okay, x to the eighth. Now I look at my bottom. So let's look at the denominator now. 1 times 7, that is just 7. And then my x's, I can go ahead and combine those. Let me use this color. So x to the 12th times x to the 5th. I am applying the product rule. So you get x to the 17th. All right. Only thing left to do here is reduce if at all possible. And right away, you should have noticed that there's 2 sets of x's here. So we have to apply our division rule, meaning that everything else stays the same, but we do have to play our who wins game there. So let's take a look at that. On the x's, which one has more, top or the bottom? Well, the bottom has more, actually. How many more does the bottom have than the top? It has exactly 9 more. So my final answer here is negative 1 w to the 14th over 7x to the 9th. All right, guys. I think, let's see. I think I'm going to let you guys off right there at that point. What I want you guys to do now on your own, go ahead and try out 6 through 8. I'm sorry, 6 through 10. So the evens on the right-hand side, because those are for you guys to try out. So go ahead and try those now on your own and double check to see if you have your answers correct from when I actually solve these. So at the end of this video, if you want, you can go ahead and stop it now. Otherwise, you can go ahead and watch the rest of the video as I solve the rest of these problems. Alright guys, but otherwise, go ahead and stop the video at this time and continue on either to your homework or just continue practicing on the you do column. Alright guys, I will talk to you later. Bye.